Okay, I'll just be attempting to go through a few key questions in this more concept worksheets. Okay, so as I go through, okay, please try the other questions on your own. Okay, first, before we can attempt this worksheet, okay, please revise through your chemical formulas. Okay, it's this one here. You know the common salts such as oxides. You know the formula. Things like, okay, even your hydroxides. Okay, and so on and so forth. Okay, things like even sulfate, sulfides. You know the difference? Know the formula? Okay, because if you do not know, you'll affect your equation writing, phosphates, nitrates, and so on. And your common gases as well as your chemicals. Okay, so if you do not know this, okay, it'll be very challenging for you to really attempt to write equations for more concept. Alright, so moving away from that, let's try a few sample questions. Okay, first you must obviously have your periodic table with you at all times. Okay, so more concept. Okay, question 1 is a typical question on empirical formula. Okay, so let's try question 1A. Okay, read the question first. What is the empirical formula? Okay, the question asks you, what is the empirical formula? So let's attempt this question. Okay, a chemical analysis shows carbon, hydrogen, and nitrogen. So I have to write a table in exam. Carbon, hydrogen, nitrogen. Typically write these elements. Okay, I have to have the mole ratio. Okay, and of course the ratio. And my final answer, the empirical formula. Okay, so carbon, okay, mass of carbon 34, mass over mR, 34 over mR. I can look at the periodic table and realize that it is 12. Okay, 12. Okay, what is the answer? Hydrogen. Hydrogen is a 1. Okay, take note it's the mass of the atom. 1 over, sorry, my bad. Okay, we take the mass, which is 3.97 over 1. Okay, what's the answer? And finally, 7.94 mass over mR of nitrogen, which is 14. Okay, mass over mR. Why? Because mole, you remember this triangle? Mass over mR is mole. Mass in grams. Okay, so we have our answer. 3 answers. Okay, we have our 3 answers. We find the mole of carbon 34 over 12. Using our calculator, we have approximately 2.833. Okay, we try to leave at least 4 to 5 decimal. Okay, this one is definitely 3.97. And we have 7.94 divided by 14. 0.56714. Okay, we can keep 3 or 4 single figures for intermediate answers. Okay, finally, how do I find the simplest ratio? I divide it by the smallest number. Okay, in this case, the smallest mole number is this. So everything divided by that, I have to show the step. Okay. And of course, okay, this one divided by itself. Okay, what is the answer? Okay, the answer, if I work it out, is approximately 5. Is to 7. Okay, is to 1. So what's the empirical formula? Okay, the empirical formula hence will be equals to C5H7N. Okay, Okay, this is my empirical formula. Don't forget to write this final answer. Okay, when can you not round it off to the nearest integer? Okay, it's when you have things like 0.3333, okay, which is equals to 1/3. Okay, so in this case, you have to multiply by 3 throughout to give a whole number of 1. Okay, things like 0.5, we do not round off to the nearest integer, we multiply throughout by 2 to give a whole number of 1. And of course, things like 0.25, multiply by 4 throughout to give a integer of 1 for your simplest ratio. Okay, so these are exceptions. Alright, okay, now moving down to the next part. Okay, the relative molecular mass is 162. Determine the molecular formula. Okay, so let's attempt this question. Okay, we know N, okay, is equals to the relative molecular mass. I will denote it by mR over the mass of empirical. Okay, it has to be a big number over a small number to give a whole number N. Okay, so we are given that the molecular mass is 162. What is the mass of empirical? Okay, this is the empirical here. Okay, 5 carbon, 5 times 12 from a periodic table, plus 7 times 1 for hydrogen, which is 7, plus 14. Okay, when we'll have an answer. What is the answer? Okay, the answer in this case is 2. So, what does this mean? Okay, the N is 2. That means the actual molecular formula is 2 times the empirical. So therefore, molecular formula, okay, is 2 times empirical. Therefore, it will be C10H14 N2. Alright? Okay, so this is how we do it. Okay, I'll move down to the next question. Okay, the next question, question 2, is a typical question using this formula triangle. Okay, mass, mR, and mole. Okay, mass in grams. Okay, so question 1, what is the molecular formula? I just need to sum up all the elements. Okay, 9 of carbon, 12, plus 8, plus 4 times 16. Okay, I won't work it out. You will get the answer. Okay, molar mass. When it's molar mass, you need the units gram per mole. Okay, when do you not need your units? When they say is the relative. Okay, with the word relative molecular mass, there's no need for units. Okay, mole of aspirin. Mole is given by what? Mass over mR. Okay, mass over mR. Okay, the molar mass. mR is given here. So plug it in, you'll get the answer. Okay, number of moles. Okay, how many aspirin molecules? Okay, I first find the mole. Okay, I know, so I take mass over mR. I find the mole. Okay, mole of substance equals to mass over mR. So what's the answer? Yeah, something mole. Okay, using this number of moles, I multiply by 6.02 times 10 to the power 23 molecules per mole. I'll have my answer, okay, in number of molecules. Okay, finally, okay, what is the mass in grams of 1 times 10 to the power 23 molecules? Okay, I know 1 mole has 6 times 10, 6.02 times 10 to 3 molecules. Okay, so this number of molecules, okay, mole, okay, in moles of aspirin in this molecule. Okay, 1 times 10 to the power 23. Okay, for the O-level track, we learn as 6 times 10 to the power 23, but for IP, it's 6.02 times 10 to 3. Okay, what is the approximate answer? Okay, approximately is actually 1 over 6. Correct? So therefore, what is the mass? Okay, mass equals to mole times mR. Mole times mR. Okay, find the mR. okay, from part 1. Okay, so equals to how many grams in 3-cific. Okay, all final answers, all calculation final answers, all should be in always 3-cific. Alright.